A personal breakthrough. After several days of intense work, this essay offers a correction to Einstein's interpretation from his 1905 and 1915 special and general relativity theories that gravity is the curvature of spacetime caused by mass, an idea still held by much of the physics community today. Here is a direct challenge to that definition. First, this does not dispute Einstein's finding that mass curves spacetime. That remains valid and experimentally verified. What this essay argues is that gravity should not be defined as spacetime curvature, because curvature is an effect of mass, not a mechanism that causes gravity. The principle of least action. This fundamental principle states that physical systems evolve along paths that minimize a quantity called action. It is this principle, not curvature, that causally describes and governs gravity. General relativity and the least action connection, A. In general relativity, the principle of least action defines the paths of physical systems. B. The Einstein field equations arise from this principle, and free particles follow geodesics, paths of least action, in curved spacetime. C. The first law of motion is simply gravity expressed through curved spacetime. D. Energy conservation holds locally, along geodesics, but not globally. E. A path of least resistance, a geodesic, is the shortest, straightest path within a curved geometry. F. From an external flat perspective, this appears as falling, or the force of gravity, but it is simply an object following the path of least action. G. When the mass is removed, spacetime returns to flat, Euclidean form. HK. The principle of least action underlies conservation of energy, the path of least resistance, and the first law of motion. Conclusion. Gravity shall be described as a consequence of the principle of least action, not as curved spacetime. Curvature is a description of geometry, not a mechanism. The principle of least action, however, is causal. In classical mechanics, bodies under gravity follow the path minimizing action, linking kinetic and potential energy, a true cause of motion. In general relativity, this extends naturally. Objects are not pulled by a force, but follow the straightest possible paths, geodesics, through curved spacetime. Thus, the equations of motion, in both classical and relativistic frameworks, derive from the same underlying cause, the principle of least action. Gravity is not curvature itself, but the path dictated by least action through whatever geometry mass creates.